Welcome back. I'm Ms. Killen here at MPB. We are still in our Unit 6 with our quadratics. So now let's look at our Lesson 3. It's solving quadratics by factoring. We are looking at SSE 3A and REI 4B. I can find factors of a quadratic equation while using the zero product property to find the solution. So let's jump in and see what we've got. All right, once a quadratic equation is factored, we can use the zero product property to solve the equation. The zero product property states that if the product of two factors is zero, then one or both of the factors must be zero. Now, let's see what all that means. To solve the quadratic equation, the first thing we're going to do is we're going to set the whole equation equal to zero. Next, going to factor that quadratic like we've done in our last two lessons. Then I'm going to set each of those factors or those binomials equal to zero. Then I'm going to write in my solution set. So let's see what this means. So I've got x squared plus 8x plus 15, and I've gone ahead and I've equaled it to 0. So what I want to do is I want to find out what the solution is to this equation. I want to know where this equation would cross my x-axis. You always want to put your answers in numerical order, all right? And then I also want to note that there is a calculator video that will be connected after this lesson, so you can go and see how exactly you do this with our calculator. So don't forget that. So let's look at this. I am going to go ahead and factor as normal. I'm getting the factors of 15 that will add to give me my 8. So I've got 1 and 15 and 3 and 5. I'm going to use this pair, and I have my x and my x. Since my second operation is a plus, I know that both of them will have this first operation, and 3 and 5. Now, this is where I'm going to take both of these binomials and I'm going to equal them to 0. So I'm going to get x by itself. Remember, when we learned all this algebra and we want to know what an answer is, we get the variable by itself. That's what we're doing here. We're getting our variable by itself. So I'm going to take this x plus 3 and I'm going to equal it to 0. And I'm going to take this x plus 5 and equal it to 0. I am using opposite operation to isolate my x. I'm using opposite operation to isolate my x. So my two zeros, my roots, my solutions are -3 and -5, and you always want to write them in numerical order. So it'd be -5, -3. Like I said, we do have that calculator link at the bottom of our lesson, so please, after we get through this lesson, go and look at that video. All right, so let's do some more like this. Let's look at this one. I have tf squared plus 17f plus 3 equals 0. So I'm going to factor this as normal. So let me get a different color so we can work this one. I do not have a GCF, so I'm going to go ahead and multiply my a into my c and rewrite f squared plus 17f plus 30 equals 0. I'm going to get the factors of 30 that will add to give me my positive 17. So I have 1 and 30, I have 2 and 15, I have 3 and 10, and I have 5 and 6. I'm looking for 15, so I'm going to use this pair right here and build two binomials. So my second operation is a plus, so both of my binomials will be the same as the first. I'm using 2 and 15, my x and my x. I started this problem off by multiplying that a into my c. Now I've got to take it back out by division. Reduce my fractions always. So I've got 1 over 5, and I've got 3 over 2. This is where my name comes from, bottoms up. So I have 5x plus 1, and I have 2x plus 3. I want to take each one of these and equal them to 0. and then isolate that variable by opposite operation, so I'm subtracting. So -1 equals 5x. I divide. So x equals -1 over 5. Now let's go to this other side. I'm subtracting 3 on both sides. 2x equals -3 divided by 2. So my x equals -3 over 2. When I write these in numerical order, I would put -3 over 2, comma, -1/5. Check your work. Make sure you're using those opposite operations to isolate those variables, making sure that when you get that fraction that you've divided on both sides. So make sure you do that. All right, so let's look at some more. It says let's do some practice. Factor the expressions and solve the zeros, all right? So let's go ahead and look at that first one. What do we got? 6v squared minus 8v plus 14 equals z. We always want to make sure we're doing what? We always want to make sure that we get those greatest common factors out. And we also have our Desmos that can check for our y's. So let's go ahead and work at pencil paper. So my GCF here, I have a 6, an 8, and a 14. They're even numbers, so I know that I can take out a 2, and then I'm going to write what's left, which would be 3v squared minus 4v plus 7 equals 0. My a, and you might want to label them, and that's fine if you do, so you can see what my a equals. Well, a is more than 1, so I'm going to use bottoms up. So I'm rewriting it. I need to get the factors of 21 that will add to give me a -4. So let's see what we've got. I've got 21, I've got 1 and 21, and I've got 3 and 7. So I can use these, bringing that bad luggage or that GCF down. I'm going to build my two binomials. I'm going to have a 3 and a 7. Since my second operation is adding, both of my binomials are going to be like the first. I started this problem off after I took out that GCF by multiplying that a into my c, so I'm going to divide it back out. Always wanting to reduce my fractions. 3 over 3 is 1. I can't reduce 7 over 3, so my bottom comes up, and I have 3v minus 7. Want to get those variables by themselves. Now, let's see what we got. I have 3 different factors of this. I have here, here, and there. 2 cannot equal 0, so I know 2 is not a solution. v minus 1 equals 0. Using opposite operation, v equals 1. Then I have 3v minus 7 equals 0. Using opposite operation, 3v equals 7, division, v equals 7 over 3. So I'm going to write my solution set as 1, 7 over 3. Let's look at this other one. Do I have a greatest common factor? I do not. So then I'm going to go into multiplying my a into c, and I'm going to get x squared minus 9x minus 90. Now, this is where you might want to look at that y equals feature to find the factors of 90. So when you see those factors, you can see which one of them subtract to give me that -9. Okay, that would be a great opportunity. So let's look and see what we got. So I'm building those two binomials, and when I look at those factors, I am going to get 6 and 15. Now I'm subtracting. That means one's going to be positive and one's going to be negative. Positive 6 minus 15 is my -9. I have my x and my x. I started this problem out by multiplying that 18 into my 5, so I've got to divide it back out. So I'm going to have x plus 1/3, and then x minus 5/6. Got to bring those bottoms up. So I have 3x plus 1 equals 0, and 6x minus 5 equals 0. Isolating that variable, so my first x is a negative 1/3. Isolate my next variable. Divide. So my x equals 5/6. So when I write this as my solution set, I am going to get negative 1/3, comma 5/6. Check your work. Check my work. Make sure that we are adding and subtracting right. Make sure our multiplication is working out. Remembering to divide those a's back out correctly. Got to make sure we've got that. You can always go to your Desmos calculator, plug in our original trinomial, and where those trinomials hit those x-axis should be negative 1, comma 3, 0, and 5/6, comma 0. So we can always double check with our Desmos. Good job. Now, time for you to do some mastery. Jenna solved the quadratic equation by factoring. She got 4, comma 6 as her solution set. Did she do the math correctly? So we have m squared minus 10m minus 24 equals 0. Go ahead and pause the video, work this out on your own and see what you get, and then come back to me. All right, let's see what we got. No, it's not. It's not correct. Okay, so Ms. Killen, why? Glad you asked. Let's go ahead and work this out. So I have m squared minus 10m minus 24 equals 0. I'm getting the factors of 24 that will subtract to give me a negative 10. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So I'm going to use these. So let's see. I've got m and m, plus and minus, positive 2 minus 12. Now, if you had used this one, and you had a positive 4 minus 6, you wouldn't have got that negative 10. So that's why it's very, very crucial that we look to see what this second operation is wanting us to do to get that middle term. That's why we've got to make sure we're paying attention. All right, so then when I equal both of these binomials to 0, I get subtractive 2, m equals negative 2, add 12, m equals positive 12. So when I write those as a solution set, and when it asks me what's the correct solution set, negative 212. Want to make sure that we are looking at that second operation, that it makes sense with the numbers we got to get that middle term. Always want to make sure about we do it correctly. All right, don't want to forget that we can use the zero property to solve our quadratic equations. We set the equation equal to 0 so we can find our factors. We are looking at those x values on the graph, that is our solutions, and we always want to make sure that our solution sets are put in numerical order, no matter what. I'm so glad you came today with me to learn. I am Ms. Killen, this is MPB, and have a great day.